Hey everyone, welcome to another video lesson. For this video lesson, we're going to summarize studying inverses. Okay, so for example, we know that when we have a linear function, the inverse of a linear is another linear. When we have a quadratic, the inverse of a quadratic is another, it's a square root. When we have an exponential, the inverse of an exponential is a log function. So some facts we know by now about inverse functions. One is that the points invert. The line of symmetry is the line y equals x on all sets of functions. That applies to all three of these so far. And then also domain and range switch, okay, and asymptotes also switch. When it comes to a cubic, the inverse of a cubic is a cube root. So with that said, I'm going to go over some examples here, and for the sake of time, I've already worked out the examples, and I'm just going to explain them. So let's start with this function here. Okay, so this is a linear. We have the slope is -1/2 and the y-intercept is 0, -1. So then 0, -1 will be this point, and then we use rise over run. So rise of 1 and then run of 2, we get this point. Rise of 1, run of 2, we get this point, and by doing the same thing, we get these other 2 points. Then to get the graph of the inverse, we take the coordinates of each one of these points, and then we switch them, and then we get the points of the inverse function. So this is the graph of the inverse of the given function y, or f of x, if you want to call it. Well, this is a function, right? So the inverse has to be a function too, because it's a line. That's something that I mentioned in class. The inverse of a line is another line. And since a line is a function, then the inverse is also a function. So then, as you can see, domain and range for the y, y equals -1/2 of x minus 1, is this. If you switch them, you get the same thing, right? And this here is a line of symmetry, which is the line y equals x. So this is linear. The next one, we're given a quadratic, and we're being told that the domain has a restriction. This is saying that the values of x have to be greater than or equal to 0, which means we can only use the right side of the parabola. So if you look at that right side, that's this graph here. So we're just using the right side of the parabola. When we find the inverse is going to be a square root. So again, all I did was I switched the coordinates, and I got, so this point, the coordinates of this point is 0, 2. Switch them, become -2, 0. This is 1, -1. Switch them, becomes -1 and 1. And the point is you get all those points. And this is the line of symmetry again. Okay, the line y equals x. Now the next function is one that you just got introduced to in the last few lessons. Okay, you had seen it before, but not to the extent or to the level that you're seeing it now. So this is an exponential function. The graph gets translated to the right 2 units and then up 3. So this is that graph, okay? And don't forget, exponential functions have horizontal asymptotes. The inverse of an exponential is a logarithmic, but again, I'm not giving you the inverse here. I'm just giving you some points on the exponential, and then I'm switching those points to get the points of the inverse function. The inverse has a vertical asymptote. So this is the vertical asymptote. This is the horizontal asymptote. Horizontal belongs to the exponential. Vertical belongs to the logarithmic function. Okay, and again, notice domain and range here switched, and also the horizontal asymptote is at y equals 3, which is this line, and the vertical asymptote is at x equals 3, which is this line here. So that's all for that one. Now let's go into the second part of this lesson. Okay, the second part is telling us if f of x equals 3x minus 8 and g of x is the inverse of f of x, what kind of function g of x would be. Well, we know that this, if we graph this function, has a slope of 3 and a y-intercept of 0, -8. So when we connect the points, that becomes a line. So the inverse of another line is another line. So the inverse of a linear is going to be a linear. Okay, so hopefully that's not too difficult to see for any of you. Okay, so the inverse of this one is going to be another line. Next question. If the function f of x equals the square root of x plus 2 and g of x is the inverse of g of x, state the domain of g of x. Now, what we know about the domain of f of x is that the domain goes from -2 to infinity, because don't forget, this is the square root function. Okay, so domain is not a real numbers. The range is not a real numbers either. So they give us the function, and then to find the domain of the inverse, all we have to do is determine the range of this function. So the range of this function, it goes from 0 to infinity. So that tells us that the domain of the inverse has to be all the values of x that are greater than or equal to 0. Okay, so that's the answer to that one. Because again, if you didn't catch this, domain is from -2 to infinity, and the range, this goes from 0 to infinity. So then the range of this function becomes the domain of the inverse. Okay, all right, and if you didn't catch that, you might want to write it down. And I decided to do that real quick for you. Okay, so domain is all the values of x greater than or equal to -2 based on this graph and also based on this function. And the range goes from 0 to infinity. So then to find the domain of the inverse function, just switch these two. So that's why the range of this function becomes the domain of its inverse. Okay, all right, next question. If f of x is equal to 5 to the power of x plus 9 and g of x is the inverse of f of x, state the domain of g of x. Well, to start off, we know that the domain of exponentials are always all real numbers. This is going to keep going to the left and to the right. The range goes from 9 to infinity. Okay, so this is the range. The range of this function becomes the domain of the inverse. So then domain of this one, just switch the variable. Instead of y, you write it x. Okay, because those are x values. All right, the next one. If, let's see. If f of x equals the log of x plus 5, and this is a common log, and g of x is the inverse of f of x, state the equation of the asymptote of g of x. Well, we know that logs have vertical asymptotes. So this graph goes to the left 5, which means the vertical asymptote is located at x equals -5. So I'm going to write that down. So VA for vertical asymptote is located at x equals -5. Well, the inverse is going to have an asymptote at a -5, but instead of x, it's going to be y. And the inverse of this will be an exponential with the base of 10. So then the equation of the asymptote, horizontal asymptote, is at y equals -5. So this is the horizontal asymptote equation. Okay, last example, true or false? If f of x equals x square root of x plus 2 and g of x is the inverse of f of x, then g of 3 equals 7. So what it means is when you plug in a 7 for x here, okay, that should give you a 3. So let's see. So if x is 7, then this becomes 7 plus 2. We know that 7 plus 2 is 9. The square root of 9 is 3, so we get 3. So when x is 7, y is 3. So that's the point we have. If these two are inverses, then we just have to have the case that when x is 3, y is 7, because the x and the y values have to switch if the functions are inverses. So then the answer to this is, and I'm just showing the work here, 7 plus 2 is 9, square root of 9 is 3. So we get 7 comma 3. So then we have to get this point on the inverse, and we do, right? So that is a true statement. All right, thank you for watching. I'll see you in the classroom. Bye-bye.